Okay, so now that we have looked at solving systems of equations with two variables, we're going to look at solving systems of equations in three variables. That's right, you get a video by me even. Okay, so first I want to look at some pictures because I think it really helps visualize exactly what we're doing. So before, when it was two variables, we just had lines, but now we have planes, as you can see. So this first picture here is where all three planes cross at one point in particular. Then that means the three planes intersect at one point, so you have one unique solution, which is x, y, z. And then you could also have this option where you have infinite solutions if all three planes cross and their crossings form a line. Then that line is all the infinite solutions that you could have. Also, you could have these three options, which means the three planes have no points in common, so the whole system would have no solution. So here, you only have the planes, two planes cross each other, and not all three planes cross each other. Same here, only two planes cross each other. And then here you have three parallel planes, so they don't cross each other at all. Okay, so now that we looked at all the different possibilities we could have with a system of equations in three variables, we're going to look at an example together. Okay. Awesome. So, let's see. Here's the first example that I want to go over with you guys. It is 4x plus 2y plus z equals 7. 2x plus 2y minus 4z equals negative 4. And x plus 3y minus 2z equals negative 8. So here we have three unknowns, or three variables, x, y, and z, and three equations, 1, 2, 3. So we're going to be able to solve the system as long as it's consistent. So we're going to try to do that. And when you have a system of equations that has three variables, you want to use elimination. So you want to first start by picking a variable to eliminate. So I kind of checked out my different equations, and I saw that we have one positive z and then two negative z's. So I'm going to pick to eliminate z first. And so I have to combine my first two equations and eliminate z, and then combine my second two equations and eliminate z. So let's start with the first two. And I'm going to cancel out z. And to do that, I'm going to have to multiply the first equation by 4 so that the plus 4z and the minus 4z will cancel out. So I multiply my first equation by 4, and I get the first equation as 16x plus 8y plus 4z equals 28. And my second equation, I'm just going to leave it alone so that I still have that negative 4z. So that becomes 2x plus 2y minus 4z equals negative 4. So just as we did with two variable systems, we just add down to use the elimination method. So 16 and 2 gives me 18x. 8 and 2 gives me 10y. And this is where we get the nice canceling out. 4z minus 4z makes a 0 pair. And then 28 and minus 4 gives me 24. Okay, so now I have a system, or an equation with two variables, which is good. So I canceled out z from the first two equations. Now I have to use the second two equations and also cancel out z. So I'm going to do that right down here. So I'm also going to cancel out z. And so looking at these two equations, I'm going to have to do multiply one equation by a negative number so that we have one negative number and one positive number. So what I'm going to do is multiply my third equation by -2 so that I can cancel out this +4 it'll become with a -4. So actually in my first equation I multiplied by -4, and this one I'm going to multiply, or +4. This one I'm going to multiply by -2. Okay, so I'm going to leave my first equation the same, so that's 2x plus 2y minus 4z equals -4. And then I'm going to multiply my second equation by -2. So when I do that, I get -2x minus 6y plus 4z equals 16. Okay, so now I'm going to do the same thing that I did before. I'm going to add down. And when I do that, oh look, my 2x and my -2x, that actually makes a 0 pair as well, which is kind of convenient. And with the 2y minus 6y, that's going to give me -4y. And my -4z plus 4z, that's also going to make a 0 pair. So that's all going to equal -4 plus 16, which is 12. So in this time, I actually got my x's and z's to cancel out when I canceled out a z, which is okay, that's allowed to happen. It just makes it easier for us actually because now we know exactly what y is. So we can continue to solve for y by dividing both sides by -4. So we get y equals -3, which is awesome because now that we know y equals -3, we have one of our three variables. So now we can plug y back in up here to the two variable equation that we found so that we can solve for x. So let's move that whole thing over here. We had 18x plus 10y equals 24, and we know y equals -3. So we're just going to plug y in to solve for x. So we get 18x plus 10 times -3 equals 24, or 18x minus 30 equals 24. Add 30 to both sides. Oops, sorry. So we get 54. And then we divide both sides by 18. We get x equals 3. So now we have two of our variables. We know x equals 3 and y equals -3. So the only thing now that we have to do is solve for z. So just as we did before, we can use any one of the original equations and plug in x and y to solve for z. So I picked plugging it back into the first equation just because it doesn't matter. You can use any one you want. So I'm going to move over here. And now I know that I take my equation for x plus 2y plus z equals 7. And we found that x equals 3 and y equals -3. So we're just going to plug in what we know and solve for z. So 4 times 3 plus 2 times -3 plus z equals 7. So we get 12 minus 6 plus z equals 7, or 6 plus z equals 7. You solve for z by subtracting 6 from both sides, so we're just left with z equals 1. So there we did it. We just solved that system of equations because we found all of our missing variables, x, y, and z. So we can write that solution as a point in 3D. So it's going to be like x, y, z. So we just fill in what we know. X is 3, so we write in a 3 for x. Y is -3, so we put in a -3 for y. And z is 1, so we put a 1 in for z. So because we had a solution to the system of equations, it's consistent, and it's also independent because we have one solution instead of infinite solutions. So I also want to show you something else cool. If you go on our handy dandy website, Wolfram Alpha, that I showed you guys before, you can just type in all 3 of those systems. So I did that already. And then you push enter or the equals button. And then it spits out all this nice information. You have the input, so what you put in. It also tells you alternate forms. And then at the bottom, it gives you the solution. So x equals 3, y equals -3, and z equals 1. Well, as you can see, that's what we got when we solved the system. So you can use Wolfram Alpha to help you check your answers by making sure that you did all your algebra right. So that's a good way to check your answers for the next couple of U-tries as well. Okay, see you guys later. Bye.